हिट नहीं कर रहा है। तो मैंने रोहित सर से
कोई बात
पूछा,
नहीं, कोई
रोहित
बात
सर ने बताया कि वर्चुअल मशीन में नहीं होता है कभी कभी। तो उसके बाद उन्होंने बाद में बताया एंड ऑफ द क्लास में कि आप और एक होस्ट से ट्राई करो, उसमें हो जाएगा। आपका
नहीं। So
कॉन्फ़िगरेशन
you
सही
just
है।
have to try with the host. You
आई
can.
डिड दैट सर, इट इज नॉट वर्किंग, इट इज नॉट
No
मूवमेंट, इट
problem, no problem. Sometimes it's not working. You try with the machine that is server instead of the host machine. Okay, Pratik.
ओके
If
ओके
there
ओके
is
ओके।
server, you can try with
यस यस
that.
सर्वर, यस
Yes.
ओके ओके।
So sometime we virtual machine not work correctly. So just try with the server instead of the machine. Okay.
ठीक है सर,
If it
ठीक है,
not
थैंक यू।
work, you
हाँ
just follow my curriculum. Whatever I'm
ओके
going to do that, it is going to be 100% work. So don't worry.
ओके
Tomorrow again,
ओके सर,
class with Rohit sir, just ask that. Okay.
ओके सर, थैंक यू सर, थैंक
All right. So everyone,
Hello, sir.
yes.
Sir, when I try to access Palo Alto Firewall, I am unable to connect my virtual PC. Sometimes it's connected. Virtual firewall is set the everything IP and DNS, everything is for Palo Alto side is okay. When try to ping the virtual PC, I'm unable to ping the PC
So
for Palo
virtual
Alto.
PC, you just have to disable the firewall on the virtual PC.
Yeah, I did. Okay.
Let me show you. In virtual PC, if you're pinging the virtual PC, so I told you there is a by default ICMP drop on the virtual PC, and you want to ping that, you must have to disable that. Let me show you how it is going to happen. Give me 1 minute. Let's this device get ready. Meanwhile, Pratik, what is difference you finding? Did you learn anything about the Palo Alto Firewall in last 1 month?
यू। यस सर, योर्स इज मच मोर डिटेल्ड।
Oh, everything is detailed. Every dinner is good. Okay, don't worry. So,
नहीं आई, नहीं आई सी, आई एम अटेंडिंग योर क्लास, आई एम अटेंडिंग रोहित सर's class.
Yeah,
Okay.
this definer I also close both
okay,
three.
Much more
different.
detailed, much more detailed. We are
Okay,
covering that SP3 architecture has been covered in much more
okay,
detail than.
okay. Thanks, Pratik.
So,
Okay, so you Sarik, you disable this one.
Yeah, I already disabled three option, but
Okay, what
also
is
I
your rack
blocked my.
number? Can you just ping me one to one your username and password? What is your rack number? Can you tell me rack number? What is the ending 4 digit?
Just 1 second, I say. No.
Just give me your last 4 digit of the rack.
Uh,
I enrolled in GUINET, sir, just because of you only.
Thank you, Pratik.
Yeah, but it was my bad luck that I
No, no,
got.
no, no bad luck. Don't worry. You enjoying with the board training, okay? So we'll discuss separately, okay? Don't worry. Okay, don't worry. Tariq, what is I can you give me the rack number?
अरे यार गुरु साहब कुछ नहीं होता, क्या बात कर रहे हैं? मानो मेरी बात, मानो मेरी
Tariq, you have a lot of background noise, man. I can take your question later then if you're not ready. Please take a class from very, quiet locations. We are studying something very engineering level. So I'll skip your questions, okay? And we'll take later once you're ready with your forward detail. Okay, so let me go here. All right. So guys, let's start the NAT. We have to understand everything about the NAT. So now the question is, what is NAT? Did we discuss what is NAT in last class or not?
No, sir.
No.
No. Okay. So I have two questions and I would like to answer from everyone. What is NAT? That is the one question. And the second is why we use, sorry for my bad writing, use NAT. Anyone?
Sir, NAT is network address translation. We use NAT for preserving private IP address.
That
Okay.
is basically used from public, private to
Private to
public,
public.
private to public translation. This translates our public network for the internet because the internet did not support private IPs.
Okay. Good. And why we use NAT?
So to conserve private IP address.
No, For according to me, that is used for the internet to because internet works only on public network, not on private. That's why I use the translation.
Yours also is correct. Mine also is correct, bro.
Okay, don't fight. Okay, that's fine. It's okay. Okay, that's fine. We are learning here. Okay, absolutely. Everyone is good.
That's why I said, na.
Okay.
Both are right.
So now we have to understand. We know the NAT is network address translation, right? But why we use NAT? You guys give the statement. If you have to go from private to public, then NAT is going to be used, right? Because private IP address is not going to interact with the internet. This is what I understand. Now we have to understand what was the problem actually NAT is going to solve. What was the problem actually NAT is going to be solved? Anyone?
A limitation of numbers of IP address.
Limitation on number of IP address. Okay, what else? So let me clear this diagram. Let's draw some analogy. Okay. Let's take an example. Probably there is one office.
It
It's
helps to hide our internal network series to public, and if we sharing our network with any third party, then it helps to hide our internal series.
Okay, that's fine. So we have the one office that is a branch 1 in India and that branch 2 in a USA. We have the ISPs in between that is a internet. Now we have the probably firewall connected here, right? This is a firewall. Here also we have the firewall connected. We have the ISP link terminated here. Now behind this, we have the switch, and behind switch, we have the one of the PC here, that is user is connected here. Another there is a switch, and there is another PC, that's user is connected. Let's see this user have the IP address because we have the LAN. So by default, what is the LAN IP address? Can anyone tell me what is the range of the LAN IP address?
10.0.0/8.
10.0.0.0 to 10.255.255.255.
There is a class A.
Class B is 172.16.0.0 to 172.31.255.255.
So the class A is going to be 10.0.0. Right? Class B is going to be, it is going to be 172.16.0.0
to
/12.
172.31.255.255. And class C will be 192.168.0.0 to 192.168.255.255.
So across the universe, means not universe, across the world, right? Whatever the computer we have, in office computer, in home computer, they are going to get the same series of IP address. Let me verify. If you guys check your computer IP address, and I can check my computer IP address, they must fall in the same range. I can show you right away. And you guys also check your side. Okay. I'm in the Mac. So if I'm going in down, you see here, my computer IP address is 192.168.0.106. Right? What's your? Can you just tell me? Can you check your IP address?
192.168.1.5.
What others? So it's still falling in the same range. What others? Can someone else check? I'm not in your control, right? Means your computer is not in my control, but you tell me your IP address. What is your IP address?
192.168.100.65.
Yeah, so they all falling in the class C or might be the class A or class B. That's a simple definition. So even I'm in India, my PC have the IP address is 192.168. Let's suppose 10.10/24. Even somebody is in USA, their PC have the same IP address. Could be, right? Agree? /24. This IP address could be the same. Now they both have to access the one of the Google DNS. Here is the Google DNS. And what is the Google DNS IP address? 8.8.8. So what is going to happen? This PC is going to make one packet. In this packet, they have the source IP address and they have the destination IP address. What is the source IP address? This is going to be 192.168.10.10 and destination is 8.8.8.8. Your packet is going to land to the firewall. Firewall is going to send this packet to the Google. So your Google is going to receive a one packet from India. That is going to be this packet, source IP address and destination IP address. The source is 192.168.10.10. Destination is going to be 8.8.8.8. The packet is going to receive from the USA to this Google again is a different packet. Second packet from USA. What is going to happen? This packet have kind of the source IP address, kind of the destination IP address. What is the source IP address? Source is going to be same. Destination is going to be 8.8.8.8. Makes sense? Now, when we receive this packet, hypothetically think about it. It is not going to come this packet on the internet, but think about this packet receive here, or might be it is going to receive because routing is going to happen based on destination. So this packet going to be delivered to the destination. When this have to reply again, so when this PC is willing to reply, my source is going to become a destination and destination is going to become my source. We all agree? Because we have to do the reverse packet, right? So my source is going to become a destination. So for this Google DNS point of view, now they have to reply back here and they have to reply back here. So they have the destination IP this one and they have the source IP this one. Destination IP this one and the source IP this one. Now this Google find I have the same destination for the US location and same destination for the India location. Where I send, it will totally confused. So what is going to happen? It's going to be not sure where it is going to be sent the packet. And just it's not two office. Might be we have the billion of the computer, million of the computer across the country, billion of devices, they're using the same IP address. And everyone is coming, then how Google is going to reply? It's very unfair with the Google because he's going totally confused. Where I reply? If I reply to this one is not going to communicate. If this will reply to this one is not going to communicate. So basically, the Google is going to drop this traffic because they don't know where I have to send the traffic because everyone is coming for a different location and saying, hey, I am the right person. Hey, I am the right person. But no one is right person. So the problem is the private IP address is everywhere, but those private IP address, if going to any public domain, the IP might be going to be duplicate, could be the same. So your public internet is going to be confused where I have to reply. So how we can actually make the communication? To solve this problem, what happened? Internet says to solve this problem, internet say any private IP address is not going to route over the internet. Any private IP address you cannot route on the public internet. That's a simple. So by default, any ISP, if you go on the ISP, they will not entertain any your private IP address range. That's a simple. Means you are coming from the private, they will not allow to make the communication. They will not allow to make the communication. So how the communication is going to happen in this case? If my private is not going to allow, then how the communication is going to happen? To solve this problem, we have the total internet, we have the 10 lakhs route, 10 plus lakhs route, which is going to be almost 1 plus million route available on the internet backbone. But those all are the public IP address. They're not the private IP address. So if I'm going to the internet, and my private IP address is not routable, so I cannot make any communication. So to solve this problem, the NAT was invented. That is known as the Network Address translation. To solve this problem, the NAT was invented, that is known as a network address translation. In this, what is going to happen? Whatever the private range you have, whenever you're going to the internet, you must have to translate your IP to private to public. So might be the definition could be to doing the translation private to public is NAT. No, it's not a correct definition. Means definition. If someone is saying, hey, what is NAT? Just translate to private to public is NAT. No, it's an incomplete answer. It's solving the problem. NAT is solving the problem. It is allowing my communication from private to public, but it's not a definition of NAT. So what is the definition of NAT? I'll explain. But for time being, you can check even my router have the same PC. But when I'm going to the internet, my ISP router, which is available in my home, they have the unique public IP address. Unique public IP address. If you check your unique public IP address, so every time whenever this PC is talking to the internet, if this PC is talking to the internet, this is going to change my private to the public before going to the internet. Else it will never going to communicate to the internet. Let me show you the live. If it is going on the internet, hold on. If it is going on the internet, this is my IP address. This cannot be route. So which IP is talking to the internet? See, I'm going on the internet. I can open the YouTube. So I am talking to the YouTube server, but YouTube server is not allowed to talk with this my private IP address. Then how I am talking to the YouTube server? How this video is getting played? Because YouTube have the public IP address. If you go on the YouTube and do the NS lookup, it is going to be public IP address. It's not the private IP address. So if you want to check what my private public IP address, which is talking the internet, you can go on your router. You can check that they are doing the NAT. If you take in any ISP router for your Wi-Fi, even your mobile, they have the public IP address. So you just go on the Google and type what is, please check it your side also. What is my IP address? Just check it and let me know. Everyone have the unique IP address. For me, it is two IP address. One is IPv6 and one is the IPv4. And this is my IP address. What about you guys? Can you just check it? It must be unique for everyone. It is never going to be same. So across the billions of people, millions of people, whatever they are doing the internet connectivity, they have the unique, absolutely unique IP address. And because of that, they are able to talk to internet. And whenever you're going to the internet, you going to translate your packet from public to means private to public, but it is not a definition. Can you check? Someone confirm what is your IP address?
Start from 120.
Everyone have the unique, not the same.
167.
Yes, for 167. What about your cars? Jesler, Maninder, Sugno, what is your IP address?
It's 69, 68 at the last, starting from
Okay.
122, 161.
No need to tell all IP address, but what about others? I just want to check.
1-1.
1-1. Sugno, you in the different country. What is your IP address? Public IP address. All right, he is probably on the mute. So you can see. So if I define the single word, what is a NAT? So we understand why is the NAT. NAT is going to solve a problem to just how to make the communication. But what is the NAT? NAT is going to be, if I define the NAT definition, which is a network address translation. This is going to be any IP to any other IP translation is equal to NAT. There is no public to private. There is no private to public. It's any IP to any other IP translation in NAT. NAT is not going to say I will do only private to public or public to private. No, it's not like. If you're writing here, you have the IP address 10.10.10.10 and you're saying that, hey NAT, can you translate this IP address to 192.168.10.10? NAT will say, yes, I will do. No problem. So what is this IP address? It's public or private? It's a private.
Private.
And what is this IP address?
Private. No.
So we are doing the private to private translation. Similarly, if I'm going to say, hey NAT, this is my IP address. Can you do the translation on the... It will say, yes, I will do. What is this? Private to public. If I say, you can do translation for this one to this one, just an example. Both are public. It will say, yes, I will do. And if I'm going to say, hey, you can do this translation public to private, it will say, yes, I will do that. So any IP to any other IP translation generator. Yes, Akash, you want to ask something? Please go ahead. पूछो क्या हुआ?
सर एक्चुअल में मतलब हम लोग जो काम करते हैं ना वो टेलीकॉम में है। तो अभी कुछ आईएसपीज है वेस्ट बंगाल साइड में जिन्होंने ना हमें मतलब प्राइवेट आईपी रेंज दिया हुआ है 172 का। और हमने वो इंटरफेस पे मैन्युअली मतलब जो डिवाइस है अपना आईएसपी का वो ब्रिज मोड पर रहता है। तो हमने जो कॉन्फ़िगरेशन किया है वो मैन्युअली उन्होंने मतलब आईपी दिया हुआ है 172 का। और वो क्या अगर हम उस पे हमने मतलब लैपटॉप पे सिंगल लैपटॉप पे भी चेक किया ना तो 172 के रेंज पे हमको इंटरनेट मिलता है। पर जब हम लोग वीपीएन कनेक्शन करते हैं ना मतलब डीसी टू ब्रांच तो हमको उन लोग एक लाइव आईपी देते हैं। तो वो कंसेप्ट कैसा होता है आप थोड़ा मतलब बता सकते हो?
I'll come to that point. Okay. Bridge mode you're talking, right?
हाँ मतलब मैं बताता हूँ आईएसपी के पास ना एक लाइव आईपी चलते रहता है। बट उन लोग जैसा हमने अगर स्टैटिक आईपी भी परचेस किया हुआ है ना तो वो हमें 172 का मतलब प्राइवेट आईपी रेंज देते हैं। 172 मैंने एग्जांपल लिया। वो बोलते हैं कि ये हमारा ही आपको स्टैटिक आईपी है और हमने वो फायरवॉल पे इंटरफेस पे मतलब कॉन्फ़िगर किया है तो इंटरनेट चलता है। पर जब हम लोग मतलब वीपीएन को कनेक्ट करते हैं ना मतलब टनल्स को क्रिएट करके अप करते हैं ना तो ये अप नहीं होता है। वो बोलता है कि पब्लिक आईपी चाहिए। तो उनके बैकएंड में जो आईएसपी का जो बैकएंड रहता है उनके पास में जो उनका पब्लिक आईपी रहता है ना वो पब्लिक आईपी डालने के बाद ही टनल्स अप आते हैं। तो ऐसा
I
क्यों
got
होता
it.
है
I
कि
got it.
मतलब
There's a bridge mode. ISP are going to save the IP address. तो वो कुछ एक टर्म यूज करते हैं. I need to use a
हाँ
टर्म की वो कुछ क्या उसको बोलते हैं. ISP are use that term. उसको मैं बताता हूँ आपको. ठीक है. Let's complete this one. We'll
चले
talk on that. Okay.
चलेगा
Definitely.
सर।
So we understand, right? This is a NAT, right? NAT having the any IP to any IP other translation that is going to be NAT. That could be the private IP to private. This could be the public to private, public to public, public to private, or private to public. Any combination you want to do that, NAT is going to do the translation without any issue. Without any issue, it is going to be happen. So what type NATs we have available in the Palo Alto Firewall. So if I talk about the NAT, especially in the Palo Alto Firewall, we have the multiple type of NAT. The first NAT we have the source NAT, right? Another NAT we have the destination NAT. Okay. Third is going to be U-turn NAT. And then we have the dual NAT. So we have to learn these all things. So what is a source NAT? Source NAT, when we have any packet, right? We have the source IP address and we have the destination IP address. When this packet received by the firewall or router and they want to go on the internet. So this having your private IP address and this one destination might be having the public because you're going to the internet and is going to public. So before it is going to the internet, your source must be translated. Your source must be translated from private to public. And destination is going to remain the public. So this is going to be your source NAT where you translating your source IP from private to public. So you changing here and this is your source NAT. Clear? This source NAT can be three flavors. The first flavor is going to be your static we can put SNAT, source NAT. This could be your dynamic SNAT, and third one could be your PAT. So we have to explore everything about. In all of the condition, you're doing the NAT, either static, either dynamic, either PAT. The condition is going to be always there. Your source IP is going to be changed. That's the source NAT. Is it clear to everyone? Is it clear to everyone? What is the definition of source NAT? We have the multiple flavor. I'll explain what is those flavor and how it is going to work. But first we have to understand what is the source NAT. The source NAT definition is we just have to change our private address while going on the internet. That is my source NAT. Now, if I talk about destination NAT, what is destination NAT? So it is going to reverse. Means, let me clear this diagram. Let's suppose I have a data center. Let's suppose I have a data center where I have hosted my server. So topology is going to be a little bit different. So let's suppose this is my data center. There is firewall is connected. Behind this data center, we have the switch. Behind this switch, one server is connected here, S1. This having IP address like 10.10.10.10/24. Now, this is your private network entire, or this is your public network, which is going to be public IP is going to be there. Now, one user is sitting here the internet. Let's suppose you sitting in the different country or different location. This is your PC. This PC want to talk with this private network over the internet. So what is going to happen? When you create the packet from here, this packet having this packet having a destination IP address, and they have the source IP address. Now catch is here. If I put this destination IP address, this destination IP address is not known by this internet. This destination IP address is unknown by this internet. So what is going to happen? If this destination IP is unknown by the internet, so it is going to be never process this particular. Right? So it is going to be never process this packet. So I cannot talk from internet to this IP address. So source might be my public IP address because I'm going to take my ISP as a public IP address. So take it's a 169.10.10 is my source IP address. But what is my destination IP address? I can use this one. The answer is no, you cannot use. It is not going to work. So how are you going to communicate? So to make this communication, might be you have to purchase the public IP address from the ISP. You have to buy the IP address from ISP. Or might be you can consider your WAN IP address as a public IP address. Once this packet is going to hit on this particular WAN IP address, then the translation is going to be happen. So basically you have to purchase, in most cases, you have to purchase the public IP address and then you have to advertise in the ISP. So let's suppose I have purchased the public IP address 113.10.10.10, 113.10.10.11, 113.10.10.12. So these three IP I purchased. I will advertise these three IP from my firewall to the ISP, might be via the BGP, or might be this ISP is giving my IP address, so they know already what is the IP address. So instead of the actual destination, I will define this as a destination IP address 113.10.10.10. Now, when the packet is going to hit on this firewall, what is going to happen? They will change my actual destination. So source is going to be again same. This is 169.x, but destination is going to be changed from 13 to actual 10 IP address. So here we are changing the destination IP address. So this is known as a destination NAT. Clear? What is destination NAT? You guys understand what is happening in the source NAT? What is happening in destination NAT? Everyone clear?
Yes, sir.
Yes.
Yes, sir.
Now, what is a U-turn NAT? U-turn NAT technically a destination NAT. U-turn NAT technically a destination NAT only. So I will explain in very detail how it is going to work U-turn NAT, but technically your destination is going to be translated. In dual NAT, if I want to do the translation for source and IP and destination IP both, completely I want to change the packet, then it is going to be dual NAT. So we'll cover one by one, U-turn NAT and dual NAT separately. But for time being, let's start doing the source NAT. Because we have to understand how source NAT is going to happen. Then we'll see how destination NAT is going to be happen. Then we'll talk the U-turn NAT and dual NAT. So we are good to start now. Please let me know. If any question, we can jump in it here.
NAT overload भी एक concept होता है वो अभी समझ
That's going to come here in the part. Oh, I'll cover that. Okay. Manjunath is asking, sir, triple PO configuration, the Palo Alto Firewall ISP will provide the public IP, just have to put credential instead of the IP gateway will provide a... Yes, that's fine, Manjunath. Yes, that's correct. Triple PoE, you just have to get dynamic IP address and that NAT is going to happen on that interface. So now let me go and explain one by one. So I'll go in the lab first. Let me see if any configuration. So I will remove the unused configuration from this firewall. That's the first requirement. We have to do that. I have to remove the unused configuration. So system info 137. So let me log in HTTPS. So now I will go here and I will remove the unused configuration, which is we have done in the past. So let me make this firewall as a new firewall. I will remove everything and we'll do from the scratch. So let me delete this all policy. So I will delete this policy from this security and we have to create from the scratch. I will go and delete the NAT policy also. So there is a source NAT we have done in the past class. And the third one, we have to go and delete the routing as well. We do not require routing. So we have to configure everything from the scratch except interface. So just wait. So this is done. Now I'll go in the network and under network, you go in the virtual router and go here and delete the static route as well. So now everything done and let me show you again. Yeah, there's no static route. Okay, that's fine. So now we just have the interface configuration. We are using this as a WAN interface, 68 IP address. This 172.16.10.1 is this IP address. And this is going to be my DMG zone IP address, just IP assignment. So let me commit this and after we'll do the verification and you'll find nothing is working. And then we have to make them workable as per the packet flow. Packet flow say, if you going to access anything very first time, let me open the packet flow also. That is going to be supporting help for that concept. Let me open, just give me 1 second. Where is my packet flow? Packet flow, packet flow. Yeah, I got it. So let me open this. So this is packet flow. So you guys tell me when the very first time packet is going to hit to the firewall, what is going to check? It's going to land in the fast path or slow path? Very
Fast path.
fast path. And then what happen if the fast path not have the session?
It'll go to
Then
the
we
slow
move to
path.
slow path.
Slow path. And after slow path, what it will check very first thing?
Check its session ID and everything.
No,
No, first thing will be your NAT and your interface packet
no,
interface.
no,
L3,
routing
L2,
and
Check policy, sir.
no,
routing. No, routing,
no
MAC.
routing routing session and
After routing, what is going to check?
After routing, it will go for NAT.
And after NAT,
Then it comes
security
firewall policies.
policies.
yes. So you
Talked
see,
about.
I mentioned that any new packet is hitting to the firewall, they are going to check three things. The first, the routing. Second, the NAT policy. Third, the security policy. If all three is going to match, then it will create the session, and this session is going to install in the fast path. And the very second time the packet is going to come, it is going to process directly. I hope it is clear to everyone, right? No confusion now.
Yes, sir.
Okay.
Yep.
So, Pratik, you clear?
Yes, sir.
Now we have to go here and see. If I'm going on this particular user PC, this PC, if I'm going there, right? And after going this, very first thing you can see IP config. This PC already I have assigned the IP address. I hope you guys know how to assign IP address, but let me show you quickly so you not forget anything. So you go here, make sure on the adapters, you go and assign the IP address like this way. You go and give the IP address 172.16.10.10. This is your default gateway. And DNS also you have to define because you are going on the internet. Without DNS, you cannot go on the internet. Clear? So I will click OK. My IP is already assigned. So very first thing, did I ping my gateway? I can ping my gateway. Now I ask one question probably. If I'm pinging my gateway, what special thing I have done on the gateway IP address? That's why it's pingable. By default, can I ping the interface IP address? By default, can I ping the interface IP address?
No.
So what I have done to it is pinging.
Management profile, we have to apply
Yes.
the.
So you guys make sure, I hope you understand, we created the management profile. In this management profile, we allow the ping SSH or HTTPS. By default, if you are assigning the any IP address on any interfaces, just recapping again. So you are saying, if this management profile is not going to apply, you cannot ping the interface. Rest your traffic is going to process. There is no problem. Your traffic is going without ping. That's data traffic is keep going. But if you are purposefully pinging the interface, it is not going to respond. So because of the management profile, I'm able to ping. So that is clear. Now, if I'm going to try on internet 1.1.1, it is not pinging. So even I'm going to put the routing. Will it going to work? Let me put the routing first. So I'll go and define the routing. So I'll go in the network and define the routing. It is not going to work. So I will go here and put the one of the default route. Here is default route. So very important note here. Please note it. If you are using the lab, which 4-digit is starting with 11, means 119, 1121, 1116, 11 like that. Your gateway of the default route is going to be 11.0.0.1. Apart from this 11, anything you have like 80, 80, 801, 2020, 3030, 4040, 9090, 9091, your gateway is going to be 192.168, 1.1. GoINet have two ISPs. Some lab are in the different ISP, some lab are different ISP. So I am in the ISP where my gateway is going to be this one. But if your last 4-digit lab is starting with 11, so your gateway is going to be 11.0.0.1. And here IP also going to be from 11 series. You can pick the IP address /8 from this subnet. Okay.
But sir, our number is 2121.
So even if the same is going to happen, 2121, same is going to happen. What I'm doing. Okay, Sarik?
Okay.
Okay.
Current obsession, please check our PC.
Sorry?
End of session, please check my lab why you're not connecting this.
Okay, I will check. Okay. So now I will go here and define the default route for internet. Now my default destination is going to be 0.0.0, and this is going to be my next hop. Gateway is going to be 192.168.1.1. And if I click OK, the default route is going to be created. Done. After that, second thing, we have to go and create the NAT policy. So I will do the NAT policy definitely. Even I commit, my internet is not going to work. You want to see that? Let me show you one of the example. So at least you see, unless or until we have the all three things, security policy NAT, it is not going to work. So I can show you before I can apply the real thing. So let's wait, guys. So you can see it's done. Give me one. So you can see this commit has been done, right? And still this PC is unable to talk to internet. So we have to define the security policy in NAT. NAT is going to first, let me first create the security, then we'll talk about the NAT. NAT is very important. So let me create one security policy. So who is going to help me to create the security policy? Who is going to help me to create a security policy? I want to, because we know how to create a security policy. We discussed that. So anyone can take lead and help me because I don't know how to create a security policy. I'm on this particular PC. I want to go on the internet. So how I can create a security policy? Any idea? What I should put here?
Let me try.
Yes, please try.
Here we can put the name for gateway to internet or whatever the name we can give.
Okay, LAN, or we can put
LAN
like
to internet.
trust to internet, right?
Yeah.
Makes sense? Trust zone to internet. Or trust LAN you can also put, okay? We can leave it. Shall I put universal or intrazone or inter? What is the best?
Universal.
Universal.
Universal is best, but
Sorry, I'm
here we-
interrupting you.
No, it's okay. Welcome.
Okay.
But universal is best, but we can use here internet also.
Intranet.
No.
Can you drop down the list? Show the name. Yeah, interzone.
Interzone, yeah, right, interzone. But universal is recommended. So we have to go in two different zones. From trust to untrust, we should require this one. But even if I'm going to universal, that's perfectly fine.
But let's try through the interzone.
Okay, that's fine. There's no problem. Okay, that's fine.
Let's find sources. Then we can add description this same LAN to internet.
LAN to internet. Okay. Policy. Rest we can ignore. Okay, let's go here. What is source zone?
Source will be trust, sir.
Trust.
And address will be this one.
172.16.10.
172.16.10.0/24. Okay.
Yes. And
now what is destination?
Untrust.
Untrust. Very nice. And what is the IP for untrust? Do you know?
No idea about the IP right now.
Internet have the 1 million route, more than 1 million, 10 lakh plus route. So you don't know where this user want to go that. So you should always keep any, okay?
Okay.
Because IP we don't know.
All right.
Application we leave any as an off, nothing. So
Any
this is
enable.
any. Now I create the policy. Policy is okay, right? So my policy has been created. Still, it is not going to work. Even a commit, it is not going to work because NAT is going to required. So now we have to do the NAT. That NAT is going to be my source NAT. And I mentioned NAT have the 3 flavors. Source NAT have the 3 flavor. And what is that 3 flavor? One is a static NAT. This is known as a 1, 2,
One.
1 NAT. Means 1 private IP,
One public.
2, 1 public IP. Now we have the another dynamic NAT. It's similar to one, but you don't have, let's suppose we have the 100 of user, thousands of user. We have to create thousands of a policy. It's going to be more manual work. Every NAT translation, you have to create a policy. But dynamic NAT, you just create the pool, thousands IP pool, and one policy. Every user is coming. If thousands user is coming, they have the 1000 IP. If more than 1000 user is coming, they are not going to IP. They are not going to communicate. That's a dynamic NAT. PAT is any user is coming with a single IP. They are going to be translated. Means we are using the overload feature where port is going to be in combination with the IP. So based on that, it is going to be on internet. So let me show you first the one-to-one static NAT. So for one-to-one static NAT, what is going to be required? You require the public IP address from the ISP. And how you can get the public IP address? You can find the free IP address from this management PC. You just go and try to ping free IP address randomly, anything. So I'm in the 192.168.1.0 series subnet. So I will try to ping like IP address 192.168.1. Might be 234. It's not pinging. Another IP 592.235. So I'll find 2 public IP address. Let me add this one also. So I'll just get 2 public IP address from ISP. In lab, I'm getting myself, but ISP you have to purchase. This is again private, but I'm using as a public. So we require 2 public IP address for translation. Okay. So any user, let's suppose this user is coming. So this is going to map with the 1 IP address. This is coming. This need to map on this IP address. Right. So let's do the one-to-one static NAT mapping. So I'll go in the NAT. Here I'll just go and put SNAT static. SNAT static 1-to-1. Okay. You can just put 1-to-1 source name. Original packet, from where the packet is coming. Can someone tell me? From where its packet is coming?
Trust zone.
Trust zone. And where it is going?
Untrust.
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 Yeah, that makes fine. And interface, definitely 1 by 1. This is my untrust interface. Okay. What is the source address from the packet is coming? In one-to-one, you have to put single IP address. If you're going to put the pool, it is not going to work. So if I have 2 PC and both have the different IP address, then I have to define 2 different entry one-to-one mapping. That's very important. So if this is the PC, might be they have the IP address 192.168.172. Let me check. If I go here, let me check. Okay, leave it. Okay, leave it. It will be ready. But this PC must have the IP address the 11.172. But I have to do one-to-one map. So here I will select the 1 IP address, not the subnet. Very important. Take this note. If you are going to put the subnet like /24/30/29, it is not going to work. It's very important for the starting NAT. You just have to put one host or /32 IP address. Destination address, any, because you're going to any destination, but source is coming from this one. But this source must be translated. Where it need to be translated? This need to be translated with static, and you have to put the translated IP address. What IP address you want to use? This one for the one mapping. 192.168.1.234. And destination not required, click OK. So your one NAT has been created. If I want to go on the second PC, it is going to be again same case. I can go here. There is another method. You want to clone this, you can clone. Means the same policy is going to be clone, and you can change the values. So same policy we are going to use, and SNAT 1 to 1 PC2, you can mention that. Okay. This can be PC. So everything is going to be same. This is going to be changed as a 11 IP address. Let me verify this. PC must have the 11 IP address. Let me check it. This PC must have the 11 IP address. So if I go here, CMD. If not, we define the IP address 11. IP config. Yeah, there is no IP address. Let me define the IP address. So I will go in the network. Change your address settings. And give the IP address 192.168. Sorry. 16.10.11. I'll put it here. That's all. So now if I'm going on this particular PC, then CMD, and I'm checking the IP config and try to ping the gateway. Gateway should be reachable. And even that PC, the 10 IP address, it is also reachable. So both PC are also connected to each other. Now I have to make this NAT rule. Everything is going to be same. This is going to be translated on 235 IP address. So destination IP is going to be changed here. Bidirectional you can enable if you want to just use a forward and reverse NAT. So in this case, it's not required. And you can just now commit the changes. So hold on. So we have done this particular NAT, and after that, we'll see what is going to happen. So I'll go here and I can commit the changes. And after commit, you will see how the magic is going to happen and how the translation is going to happen. So now I'm going to almost done. And if I go on this particular user PC, see it is start pinging now. And if I go this PC also server and try to ping now, let me try to ping 8.8.8 minus T, it is also pinging. So now both PCs start pinging to the internet. But how the NAT is happening? How I can check that? So let me log into the my firewall as a CLI. Even GUI I can show you, but let me log into the SSH admin @ 192.168.1.68. So I'm going to show you the live how this is going to be, show you the actual translation. There is two different IP and both are going to map in the different IP address. So now I'm in the firewall. So you just check the command, you run the command here. You run the command, you're going to see some magic here. Show session all. See here. Now look very carefully. Now look very carefully. We have done the translation. The packet is coming, this one. 192.168.10.10. It is getting translated. Source is getting translated. See here. Original packet is getting translated on this IP address. 235. Clear? Clear? We done this same one. And destination is going on this. So original packet was this one. Translated packet is this one. So this is original. If you go for a 10 IP address, see this 10 is going for the 172.16.10.10, but it is getting translated on 234. Make sense? And most important, you see the flag here. This all is NS. NS is equal to NATed source. Clear? So you guys see one-to-one mapping is happening how? It's clear?
Yes.
Yes, sir.
Now, if I have a third PC, will it going to talk to internet? If let's suppose I have a third PC on the same network, it is going to talk to the internet. What do you guys think? If I connect my
No,
third PC, can I make the communication with the internet?
no,
Why?
that is
Yes, the
one-to-one netting is happening there.
Yes. So if there is a third PC, if I just put here IP 192.168, sorry, not this is 172.10.13/24, and going to give the IP address 10.1, right? And if I try to put it here, so you can say show IP, it is going to be there. But if I try to ping the gateway, gateway is going to be reachable. But if I go and try to put the another IP ping, probably I just try to ping like 1.1.1 again. This is never going to work because we have done one-to-one mapping, and that one-to-one mapping is not in the firewall, Palo Alto. So how it can be happen? We can do the mapping, we can create another rule, and we have to find again another public IP address and do a translation. This is the one way. Another way, I can disable this all, I can delete this rule. And now instead of the one-to-one mapping, I can create the pool of the IP address. I can create the 5 pool of the IP address. So let me see if my next 5 IP are free or not. Let me see. So we just ping 35 is free, 36 is also free, 37 is also free, and 38 is also free. So we find the 5 public IP address from ISP. So I'm just going to create now source NAT with a dynamic. And in this, I will dynamic source NAT. This is going to be same. This is going to be same. But here I'll just put my whole subnet. But even I put the whole subnet, but I'm going to create only 5 pool. So whosoever is going to come from the source, first 5, they will get translated. Remaining will not going to get translated. This is very important, guys. Even I'm putting the /24. How many valid IP is going to be there? 254. But out of the 254, I'm going to only give the pool here 5. So that is going to be start 192.168.1 dot. What was the start range?
35.
No. Start we taken from here. 234, right? 234.
Yeah.
192.168.1.238. So you can see this is getting starting from 234 and 235, 238. So total valid 5 IP is there. So by default, it is going to take IP from this range. Any PC, earlier they were done translation from this IP address 234 and 235. But now they will do, or let me do one thing. Let me do the translation from this range, 236 to, let me try, I'll just find the new range. 239 is free, yes, free. 240 is free, free. Okay, so I will put this 240. So now they will get completely different range, 236 to 240 for this same PC translation. So I'll click it here and I'll commit. Now you will see that how this is getting translated on the different IP address.
So the current scenario, there will be the old session will be valid, right?
No, they are going to be changed. You will see. You might be realize one packet is going to be drop. See, one packet drop. You can see. So when that has been changed, the packet has been dropped, but it is going to be retranslated again. See, again, 3 packet has been dropped. This also 3 packet has been dropped. And this PC, you can see, this is start pinging. They start pinging automatically. I haven't done anything. But now if you go on the, again, the translation, if you just go and log into the firewall, okay, you'll see now we have the different entry for all 3 IP address because they are going to get from the pool. The pool we have defined. So I will go and put the IP address. The pool I'll get from here and you'll see wait, it will take later time. You can check from here as well. So that is processing. So if you want to see the live, you can see from here as well. You go session browser and the same is going to happen here as well. Only probably you're not going to see the flags. Now you see here. So if I go here and show session all, you're going to find 11 is getting translated on the 240 IP address. Automatic, I haven't done anything. 10 is getting translated 236 and 13 is getting translated on the 238. So they are getting random IP address from the pool. So if I add 2 more PC, they are going to be get translated on the same IP address. This is known as your dynamic NAT. Now, what is the problem with these 2 NATs? In these 2 NAT, static is the problem. If we have the thousands user, you require thousands public IP address. And you are going to purchase this public IP address, you cannot buy this public IP address easily. You have to pay money, plus you have to give justification why you are getting this. So it's very challenging to get the public IP that much from your IP assigning authority. INA is going to give that. So you're not going to get easily. So even if you have the money, you cannot purchase IP address. Second, you have to do a lot of manual configuration one-to-one. So static is useful. Somewhere you can find the static NAT is going to be useful for one-to-one communication server to the client, but it's not very frequent. Now with the dynamic is going to solve your issue where manual work. You create the pool and put the IP thousands in the pool and automatic the user is going to be getting translated. But problem is again, but you have the thousands user, you require thousands public IP address. Then it is going to work for you. So again, you have to pay. So again, it's going to be problematic because IP is not available public freely. So what is the solution? So overcome this static and dynamic, we have the third solution that is known as the port address translation. Clear? We are using port address translation. In this port address translation, what is going to be happen? You just require single public IP address. Whatever the connection coming from the LAN, they are going to get translated to a single IP address with the port number, unique port number. So you don't have to worry about the any more public IP address. You just have the single ISP IP address and you can just do n number of translation on that IP address. This is the beauty of the PAT. Just it is going to overload. So 99.99% case, you are going to find this source NAT, which is the PAT. So how it is going to happen? If you go in the policy NAT again, and you want to define the source NAT this time, source NAT with the PAT, you can go here. This is going to be same. This is going to be same. This is going to be same. It is not going to be changed. But here you not have to use dynamic. You not have to use the static. None. You just have to use dynamic IP with the port. And here you can put one of the IP address if you have any ISP IP address, or you can go here and select the interface. That is your WAN interface. And put the interface name and put that IP address. So everything is going to be translated on that IP address. So whatever the PC is here, they all are going to translate it on that IP address. So you see now we have the different translation, but the moment I will commit that, they all are going to translate a single IP address, that is a 68.68. So the port number is going to be added randomly on the every translation. Just wait. We'll see that. Let's wait. And probably you'll see that there are some packet loss, this one, and this one. But we have the again translation. Now, if you go and again see that NAT translation, you're going to find let me relog in again. Somehow I get exit. You see, now 13 is getting translated on the 68. 10 is getting translated on 68. 11 is getting translated on 68. And every is source NAT. But this is happening due to pattern. So every IP which is coming from the LAN, they are going to translate on the single IP address. I hope you guys are clear what is the source NAT.
Sir, there is one number in the bracket, that is a port number.
Which one? Okay, yes. In bracket, right? You're talking this one, right?
Yes.
This random, right? You can see. So everyone have their
1.61, 1.68, 19560. These port number due to overloading.
yes, they are just including the port number due to overloading. You can see random port they're selecting anything. You can see this is a one port they're selecting. This is another port they're selecting. So anything they're selecting is a random number. Just for overloading.
what is the limit of using this overloading IP?
65,655 maximum means whatever the port number, it is going to be max source NAT session with PAT in Palo. It's going to be 65,000 something. It is going to be maximum session this one. And ISMA FortiGate have 65,000. Let me tell the FortiGate also. FortiGate have some different number. The maximum port for the maximum, this one, you can use this one for the FortiGate 60416. And Palo, we have the maximum number, but how much we can use that? Let me share how much Palo Alto. Yeah, Palo Alto is same, right? This is maximum you can use 65536. But in the FortiGate, we have the 60416 as per the official documentation. Okay.
So once this limit start filling, then we need to add one more IP.
Yes, one more IP, right?
So
Whatever.
we just need to add there. There's no new policy or new translation is required.
No. In that case, what you have to do that you don't have to use the interface IP address. You don't have to use the interface IP address. Instead of the interface, you have to use this one, translated address. And here, let's suppose you added one IP address. So it is going to fill. So you just have to one more IP address here. Keep adding one IP address. It is going to be automatic translation. That's all.
Okay.
Clear, Maninder?
Yeah, clear.
All right. So I believe we are good for the source NAT especially. I'm not going to touch destination NAT, dual NAT, and the util NAT. Probably we'll talk in the next session. But if you have any questions, please let me know.
So in the Palo Alto, there is max source NAT session is 65,536.
Yes, right.
So some reserved ports and dynamic ports, custom ports, something like that, right? The Palo Alto will not consider that one.
Anything coming from that range, it is going to be translated. Means we have the 1 to 655 36. Everything is going to cover on that range. This is the range, right?
Yeah.
So what is the custom port? Let's suppose this lab have the customer 8,000. It is going to part of this range only, no?
Okay. Some well-known ports also there, right? So that one also.
Yes,
it will,
that is also. That is
okay.
also. You don't have to define the port manually. The firewall is going to check random automatic, okay? So you don't have to worry about anything. Even
Okay.
it is going to automatic take any port number. You don't have to give any manual intervention. Okay, so let me stop and let's check the Sarik lab. Hold on. So let me stop my sharing.